Hello guys, welcome back to the Digital Aviator channel, and this is part 2 of the basics tutorial on Microsoft Flight Simulator. So in the previous video we have explored the controls and we made sure that we know where the controls are and set them up however you want. In this video I'm going to show you how to start the engine of a single engine piston engine plane, which is what this is. There's a couple of other engine types. I might make some videos about those later, but the most simple kind of planes like this one will have a piston engine and usually just a single one or a single propeller which is connected to the engine. And these are actually a little bit more difficult to start than your car, and I'll talk about it in a sec, but let's just take a look outside. We have a slight problem here. The simulator for me has parked me facing the fuel station here. And planes don't have a reverse gear, you can't reverse with the engine running. So what you would do in the real world is not make sure the engine is not running, step outside and push the plane back. We can't do that ourselves, but luckily there's a key combination, Shift and P. So hold Shift and then press the letter P, and that will make you push the plane back. Oh, actually I forgot to release the parking brake. Let's do that first, otherwise it will be quite difficult. So parking brake released, and then Shift and P starts pushing the plane back. So we'll just do that for a couple of seconds once I'm happy with that. And then we press Shift P again to stop the pushback. And I'll go into the cockpit and set the parking brake again, so that we don't move if I go to start the engine. Alright, so now that we have some space ahead of us to make a turn, let's start the engine. So there's two things to know about starting this kind of engine. It's a little bit different than starting a car's engine. So let's just click on the yoke to just hide it for a moment. And we see that we have a key here. But in a car, if you rotate the key once, you turn on the electricity, rotate it again, you turn on the ignition, and rotate it once more, and you hold it there, it starts the engine. Well, let's see what happens in this plane. I'm going to click on the right side of the key to rotate it. I don't see any electricity coming on, and I'm going to hold it all the way in the right position, which actually says start, but nothing happens. So there's two reasons why the engine didn't start. The first is the ignition system in the plane. That's the thing that creates that burns the fuel. It creates sparks, electrical sparks that burn the fuel to create power. That ignition system is different than the one in your car. So in a car, the spark plugs in your pistons or in your cylinders where the fuel will be ignited. That power, that electricity, comes from your car's battery. In a plane, it doesn't come from the battery. We can actually turn the battery on and off with this switch. So it's not with the key, it says here a switch, and you can see all kinds of devices turn on. So now the battery is on, but we are now not igniting fuel if the engine would be running. It's a different system, and the reason for that is that in a car, let's say the battery suddenly failed, it died, you had a short and the battery is drained. Well, the worst thing that will happen is that the engine stops, but you're on the ground, you're just cruising along, so you'll just gently roll to a halt, and that's it. In a plane, however, if the engine stops because you have a battery problem, maybe something went wrong with my radios or other electronic equipment, and if the battery suddenly didn't work anymore, well, if that would power the ignition system and the engine would stop, I mean, I'm flying, I don't want the engine to stop for very obvious reasons. So in a plane, it's a little bit more safe. The ignition system is not connected to the battery. Even if the engine was running and I would actually turn the battery off, the engine would still be running. It's on its own system. And it uses something called magnetos. Magnetos are basically dynamos, and there's two of them. One on the left and one on the right of the engine. They're connected via gears to the engine, so as the engine is running, those dynamos start spinning and generate electricity, and that will be brought to the spark plugs which ignite the fuel. That is what we actually see on this key. We see right, left and both. So I can select to use only the right magneto, only the left, or both. So during a flight you'll set the key to both after you've started the engine, so that in the event that the left magneto, let's say, actually failed, we are still using the right magneto. So not only are we not relying on the battery, we also have two magnetos, so that even if one of those fails, we still have a backup. So on the plane always use the both, but before we will take off, we will actually cycle the magnetos on just left and right to make sure that they are working, because if one has failed, we wouldn't notice it if we were running it on both. So now if I turn the battery on and then rotate the key to start, it will actually engage the starter engine, which will spin the propeller around, which will crank the engine. You can see that happening here. But the engine didn't start. And the RPM, which you see up here, so that's the tachometer, the RPM indicator. It went up a little bit, but it went also down. So the engine didn't start. It's just the electrical engine spinning it around. So that's the next thing that we need to configure, and that's the fuel. There isn't any fuel going into the engine. Let's just turn off the ignition for now and the battery. There's no fuel going towards the engine, and there's two things we need to adjust. First, actually there's three things we need to adjust. First is down here below the seats, we have this little thing. This is the fuel shuttle valve, which is closed currently. And this is kind of something that you just turn on, or that you close, when you just park the plane. And it will shuttle fuel from leaving the two fuel tanks. There's one fuel tank in the left wing and one in the right wing. So no fuel can enter the engine or leave the fuel tanks, which is good if you don't want that to happen, right? If you don't want the engine to run, you cut off the fuel. So let's just click on this to open it. So now fuel can leave the fuel tanks. So now the next thing we need to configure is the throttle and the mixture with these two levers, the throttle and the mixture. So let's talk about mixture first. This is different than in a car again. So in a car, the car just sends, it measures the mixture of how much fuel to add to the air. To create a combustible mixture, you need oxygen and fuel, and the oxygen comes from the air. So the car mixes that itself, depending on how the car is being designed to work. But in a plane, we want to have manual control over how much fuel we are adding to the air. So you need three components for to burn off the fuel to create power. You need oxygen, which comes from the air. You need fuel from the fuel tanks, and you need heat, which comes from the sparks, from the spark plugs. So the spark plugs are controlled with the magnetos. We control the fuel with the mixture. So the more I push this mixture control in, the more fuel I am adding to the airflow that goes into the engine. And if I pull the mixture all the way out, we actually are cutting off the fuel flow, so no fuel will be added and only air goes into the engine, so basically it wouldn't run. Now the reason why we want to control this is that when I move up into the air, the higher up I go, the less and less oxygen there is, because there's less air. So if I'm sending the full amount of fuel into the engine, we can flood the engine, and there will be all kinds of fuel left behind that didn't get ignited because there's no oxygen. So it creates a residue, and if that builds up too much, it might cover the spark plugs and then the sparks won't fire. And then, well, the engine might start to stutter, we'll have way less performance, and in extreme cases, the engine might even shut down. So we need to set the correct mixture as I'm flying, and I'll show you how we do that once I'm in the air. But that is why we want to control the mixture. So the higher you go, we actually want to have less fuel added to the air because there is less air. So we need to get that ratio of air and fuel correct. Now, the reason why this is a red lever and also why there's this safety button we first have to push in before we can move it is because if you pull this out, you add no fuel and then of course the engine would shut down. So that is a little bit of caution there. Now, this is actually not a big deal. If you accidentally pull the mixture out, you can actually just push it back in and the engine should restart. But it's something you just don't want to do accidentally. So a little bit of caution with the mixture. So that is the other thing that we control. I'll show you how all of that works as we are flying. But the reason why we didn't start the engine a moment ago was also that the mixture was cut. So even if I opened the fuel shuttle valve, we still didn't send any fuel into the mixture. So then to the next to the left, we have the throttle control. And this controls the amount of that mixture we are sending into the engine. So the mixture controls the ratio between air and fuel, kind of the condition of our fuel. And the throttle controls the amount of that combustible mixture we're sending into the engine. So idle throttle sends only a little bit, so the engine stays running at very low RPM. And then the more throttle we add, the more combustible fuel-air mixture we send. And the higher power, the more RPM we will get from the engine. So the throttle controls the power. So then the final thing we need to do right now to start the engine. Right now there is no fuel anywhere near the engine. It's all in the fuel tanks above our wings. And if I try to start the engine actually powers its own fuel pump, but that is not powerful enough to send the correct amount of fuel into the engine right now. The engine needs to be running for that fuel pump to get the correct amount of fuel. So we need to do something that's called priming. And that is just pumping a little bit of fuel towards the engine ourselves so that there is fuel near the engine that can be ignited. And then the engine will power up and that will kickstart the fuel pump to keep itself running. So on the left here we have a primer, and if we click that, we can prime the engine. But for that we first have to control the mixture and throttle a little bit. So to prime the engine we'll add full mixture and a little bit of throttle, about 1 centimeter, push the throttle in, 1/2 inch, 1/4 inch, somewhere around here. So just a little bit. Make sure the fuel shuttle valve is now open, so rotate it to the left. and then I'll click prime. So you just push and pull this lever in, and this pumps a little bit of fuel into the engine. So now I'll send the mixture back out and a little bit in, just about a centimeter, like a throttle. So the throttle and the mixture are both a centimeter in. Then I'm going to turn the battery on, make sure the parking brake is set by pulling out this lever, which it is at the moment. And then I'm going to rotate the key to start, and this should start the engine. There we go, it started. Let's release the key to both. And then I'm going to apply full mixture. There we go. And so now we're sending the full amount of fuel. You know, we're close to sea level, so that's perfectly fine. And I'm going to lower the RPM to 1000, which is kind of the RPM that you want to be at as you're stationary on the ground. So I've adjusted the throttle down to do that. Nice. Okay, so one other thing to configure, you see this little red light turned on. That is the warning light for the ammeter. The ammeter shows the charge or discharge on the battery. And currently we are still discharging the battery. And the reason for that is we haven't turned on this red lever, the alternator. The alternator is a generator also connected to the engine that charges the battery. So if I click on this, we are now hopefully creating power to charge the battery back up. We see the red warning light is out, and we are slightly charging the battery. So everything is happy, and we are good to go. Now there are some more mixture controls. We can actually fine-tune the mixture on the ground a little bit, but let's just ignore that for now. We don't really need to worry about that in this simulator. But in the real world you would lean the mixture, a little bit less mixture on the ground to prevent flooding the engine on the ground. For reasons I will not go into right now, we'll just ignore that. But yeah, now we have started the engine. Oh, and one other thing that I forgot. We should have turned on the beacon light, which is this external red flashing light here, which is kind of a warning light that should be on before you start the engine. So that, you know, when people are walking by your plane, they know that if the beacon light is flashing, you are working on the plane, you're about to start the engine. But you know, we just forgot that. But it should be done before you start the engine as well. Alright, so next, let's go ahead and taxi to the runway. Oh, no, actually, before we do that, I forgot one other thing. And that is to calibrate some of our flight instruments. Now, I will talk about these instruments as we go on. But for right now, we have this indicator and this one. This is your heading indicator, and this is the altimeter. And both can be calibrated. They have a little knob next to them to calibrate them. You can rotate them, so either click on the left or on the right, or easier, use your scroll wheel on the mouse while hovering over these knobs. You can calibrate them. So why would you calibrate your heading? Well, this is actually not a compass. A compass uses a magnet to point north, and there's a spinning disc next to it that will translate into the the current heading that you're on. This is not a compass, there's no magnet here. This is powered by a gyroscope, but this gyroscope will only spin, keeping the heading stable. So as the plane turns, this will stay in the orientation. So it shows me that I have turned. So this will just rotate in the direction I've turned. But it will also only work if the engine is running. So a moment ago it wasn't running. And it could have been, you know, all over the place. I don't know what it was before. But, oops, it could have been, you know, whatever. It is probably not correct. So we will look up here. And this is an actual magnetic compass. This points towards north. There's a magnet that points north, but the disc points towards your current heading. So the 6 means 60 degrees. East is of course 90 degrees, so this will be 70, 80, so this will be 75. So I know my current magnetic heading. So I can calibrate it to 75 over here. So there is 60, there is 70 and 75. There we go. So that is how we would calibrate that. Now, why would you prefer a gyroscopic heading indicator over a magnetic one? Well, if you've ever held a compass in your hand before and you just move it a little bit, you shake it a little bit, you know that it's spinning all over the place. You have to keep it very stable in order to read a correct, stable heading. This thing will also spin all around as it moves. So as the plane moves through some bumpy air, or if you're making a turn, it is very inaccurate to read this. This, however, is extremely accurate. So that's why you will rely on your gyroscopic heading indicator rather than your magnetic one. So then we'll talk about this indicator, it's the altimeter, and that can also be calibrated because this relies on air pressure to show our altitude. And the air pressure outside can change, so we have to set it, and you can see some dials or some numbers on the left and the right. These are units of air pressure, millibar. Also the same is hectopascal, so millibar and hectopascal are the same. And we have inches of mercury on the right, which is the American unit of measuring air pressure for aviation. So we will calibrate this knob, and you'll see that the units move around and also the needle moves around because it thinks we have a different air pressure. So of course it uses air pressure because the higher we go, the lower the air pressure, and it can measure that to tell us our altitude. There's 3 needles on here. The long narrow one, which currently points to 4, is the hundreds of feet. So right now it points to 400 feet. The short one points to thousands of feet. So you can see it's in between 0 and 1. So this is indeed 400 feet. If this needle would be in between the 1 and the 2, it will be 1000 at 400 feet. And the long narrow needle with a triangle on top is the 10,000s of feet. So we're pretty close to 0. 1 would be 10,000. So let's hope that will work. Now we need to calibrate this. So we can get some official weather sources, or we can listen to a radio tuned to an airport. That's all implemented in the sim. But let's keep it simple for now. I'm just going to go to the weather settings. And as you have this settings button here selected, which we have, we can look on the bottom of this list, and it says the pressure at mean sea level in hectopascal. And that is the same as millibar. Not sure why it says hectopascal and millibar here, but those units are the same. So 1013. So if we look over here, so right now I'm pointing to 1015. So 1013 would be around here. So here's 1010, 1011, 1012, 1013, 4, and here's 5 again. So this is now calibrated, and it says that we are just above sea level, about 50 feet above sea level. You just have to know that, that is correct based on the altitude or the terrain elevation of your airport. I'm not going to go into reading charts, which will tell you the elevation on the charts, but I'm just going to tell you that this is correct for this airfield. So as long as you calibrate this correctly, it should tell you the correct elevation or the correct altitude. Notice, however, that even though I'm on the ground, this tells me that I'm above the ground, or at least above sea level. This tells you the altitude above sea level, not above the ground. So that's something to keep in mind. Alright, so that's enough talk about the instruments. We'll talk about the airspeed indicator and the vertical speed indicator later. Let's pop our yoke back on and let's start taxiing. So let's just hop into the drone camera. If you forgot how to do that, watch the previous video. And I'm just going to look around, move up a little bit, and just look at the airport. I'm not going to deal with reading charts in this video tutorial. We'll just use the drone camera to just go up a little bit and figure out a path to the runway. So I see there's a runway here. That's runway 23. So I can just take this taxiway towards runway 23. There's all kinds of other things to know about choosing which runway and which side of the runway. It has to do with the wind direction, but I've selected the weather preset, which has pretty much no wind. Whoops. Uh-oh. I'm messing up my drone camera here. Let's move back. There we go. So just going to pop that drone camera back at the plane so I don't lose it, and then hop back into the sim or hop back into the plane. So I know how to taxi. So now we can just release the parking brake. Remember that we steer the plane with the rudder pedals, and make sure you remember what the brake button was. And I'm going to release the parking brake, and maybe the plane will already move forward, or we just add a little bit more power. Only very small amounts, just above 1000 RPM should do it. There we go. And I'm going to press the left rudder pedal in to start turning to the left. And then I'm going to reduce the throttle back all the way to idle, because otherwise we'll accelerate quite a bit. And for making turns, that is not really nice. So whenever you want to accelerate, move the throttle up a little bit. And if you just want to keep the current speed on the ground, just go all the way idle throttle. So you don't accelerate anymore. And if you want to brake, you press the brake pedals. So let's add a little bit more throttle to speed up a little bit. But you really accelerate quick on the ground here. So only for a couple of seconds. That is enough to just move forward. So now I'm going to take a left turn here. So I'm just going to brake a little bit. You don't want to go too fast. About a jogging speed is a nice speed to taxi at. So let's follow the yellow lines. The yellow lines are always in the center of the taxiway. So once you stay on the center line, you know that you're not going to hit anything with your wings on the left or the right side of the taxiway. And then we see those red signs over there. That is the runway sign. So that tells me that I'm approaching a runway. And we also see this line that's crossing the taxiway. That is the runway threshold line. So basically, if you cross that line, you're technically on the runway. So I'm just going to park in front of it. Right about here. Let's set the parking brake again. No, let's set the parking brake again. And every time you're stationary on the ground, let's just apply a little bit of throttle to go back to 1000 RPM. The reason why you do that is to not cool the engine too much, because you need quite a bit of hot oil in the engine for it to fly correctly, but that's not really simulated in this plane. But there we go. So that is how you start the engine, calibrate some instruments, and taxi to your runway. So in the next video I'm going to talk about taking off and controlling the plane during the climb.